Hi, good morning, and welcome to the Far West. Today we are going to talk about the status of the web, and we're going to talk about the good, the bad, and of course, the web components and how they fit in. How many developers are in this room? Web developers? React developers? Oh, that's kind of good. Using web components? Only one of them. All right. It's going to be very interesting. Okay, just a quick introduction first. I'm Adrien. I'm the CTO at Zenika. You can find our booth over there later. Sorry, my presentation is full of very bad jokes. It's just a disclaimer now, just so you know. Just a quick word on myself first. I have many years of experience in web development. I started with IE6 back then as well, a bit of debugging on IE5, if I remember correctly. I work with Flex, I work with many frameworks, and I've been working with web components for a while now, so this is what this presentation is about. All right, welcome to the Wild West. It's a bit messy today, the state of the web. As you can see, we're a bit lost. It's full of good, of bad, and we got the web components in there. So I invite you to follow my voice and to let me guide you. All right? So first things first, we got some good in there. All right? Today, web development has never been this interesting. All right? We got new concepts every time. We got React, we got new versions of React coming over. We had this past year's virtual DOM, we had SSR. We came back to SSR actually because we had that before. We have new technologies. We can write in any languages for the browser. So we are at the frontier and we're trying to push it. This is kind of good because we're getting very creative and we have a lot of solutions now to be very productive creating applications. So that's the good thing. We produce creative framework, productive ones, and accessible ones. The problem is, we got some bad as well. One of the bad aspects is that it becomes very messy. People today don't really need to know how to do proper web development. Most of the time, they start with a framework. They either start with Angular, with Vue.js, or with React. And somehow they lose sight of what is web development. How is it a bad thing? We're going to try to dig that a bit afterwards, all right? So just so you know, we are going to focus on this sentence, is the browser not enough? Why do we need additional runtime on top of the browser? And then we're going to talk about the web components in all this. How do they fit in, all right? Web components today are a way to unleash the power of the DOM, the power of the platform directly. So why are we not using this over frameworks? That's a question we're going to try to answer. We're going to try to address these issues as well. Is the API of web components powerful enough to compete with the big frameworks out there, the shiny ones? Do we have any gains from dropping them? Because I've told you they're very productive, everybody loves them. And then, is there any trade-off? What can you gain? What can you lose? Okay. And why do I imply that web components are ugly? I'll let you see that for yourself. Okay, this is our quick draws planning. We're going to have a lot of duels during this hour. We're going to talk about the history versus the future. So the history of componentized architecture and why we went to web components at the end. And we're going to talk a bit about the future, what's in store for us. We're going to talk about the pros versus the cons. Well, our problems first and how web components can solve them. What are the pros of using them? What are the cons? And then we're going to have the final standoff, which is good versus bad versus web components. All of you have seen the movie, The Good versus the Bad, or The Good, the Bad, and the Ugly? Yeah, raise your hand. All right, so there are some references in there, so try to keep up, sorry. First, let's talk about the history of componentized architecture. We have component-oriented frameworks these days, and they're the thing. I mean, they're very trendy. When you talk about React, when you talk about Vue.js and Angular, these are the top-notch ones. If you look at all the state of the web surveys, they all talk about them. So we have to understand what a component is in the first place. A component is this piece of item. It's an element that will compose a view or a page. Okay, so we're talking about front-end development. We're talking about things that we can actually see in the browser. Components are reusable, they're shareable, so that's one of the main things. We can just distribute them. They're configurable, meaning that depending on the context of the page, of the view that you want them in, you'd have to configure them. You'd have to have incoming parameters. And then they're extensible. I might take a component, I might tweak it a bit, and make it my own, and have it in my view. This is what it all boils down to. So technically, a component is always this. Take any framework out there, take the web components as well, and we're going to have that. We're going to have incoming props. So example, for this horseshoe here, if I want to have this, my props would be how many holes are in there. Okay, I would shape my horseshoe. Then I would declare my component itself. Its component horseshoe is this tag here. I declare it. I would put that in a page or in a view. So that's the element, okay? I have my props configuring my element. Then I have my state of the component. It's how worn it is. Is it dirty, for example? It will decide on the rendering as well. It will impact the rendering. And of course, we got the render function that will give us our horseshoe. So if you think about the concept of a component in React, in Angular, in Vue, in web components, it's always like that. In web components, you got the DOM, so basically you would work with attributes, okay, to have the props incoming. You can work with JavaScript properties to have the state. You got your element, that's HTML, and then you got the rendering, that's what you see in the browser. For a few features more, what web components try to do is this. They try to give you an API to offer you the possibility to create components directly interpreted by the browser. All right? And they do not give you just one way of doing it. They give you a set of features. One of these features, and the main one, is the custom elements feature. Custom elements is, as we've seen before, we had here this component horseshoe. All right? This is the tag. But we want this tag to be interpreted by the browser directly. We want this tag to be rendered as the horseshoe. And custom elements are this. They will get interpreted directly by the browser. They will trigger some JavaScript underneath, and then you would see the horseshoe. We got Shadow DOM. Shadow DOM is here to answer a particular issue, is encapsulation. When you have a component and you get it from somewhere, for example, when you have it in your application, you don't want its CSS to link to your application. You don't want it to be like messing around with your code, so you want it encapsulated. And you want to have extension points where you will manipulate it. Shadow DOM will allow you to do that a bit more. More on that later. And it allows you for composability. I'll talk about it with the right side in a moment, sorry. Then we got HTML template, that's the third one. HTML template, if you remember, I told you that web components or components in general should be reusable. So why not have a template that we can clone and we can put anywhere? So this is what HTML templates are like. And back then we could put anything in the HTML template because at the end of the day that's what we render in the browser. So we would have JavaScript in there, styles, anything, and then we would just replicate this and we would have a component that could be copied over. So these are three different APIs, but we can use them independently, except for Shadow DOM, it needs to be used inside custom elements. But custom elements can be used without Shadow DOM, for example. If you don't need encapsulation, why not bother? People are afraid sometimes about Shadow DOM, because that's like a document inside a document, and they tend to fear that a bit. But be aware that you can actually use web components just by using custom elements. That's enough. It's going to be interpreted by the browser anyway, and it's going to trigger the rendering that you want. You won't have encapsulation though. And there was this thing about code splitting. One of the best things when I use the framework is that I know that I can have a file dedicated to one component. I can have these modules. And today we have ES6 modules, but they're not that powerful enough. You need to have the, how do you say that? You need to target exactly the resource that you want to fetch, but it has to be relative to the resource you are on currently. That's not very convenient. But we have other tools for that. We have Webpack, and I'm going to talk about it a bit more for bundling. So for now, we don't have a spec in web components that allow you to have code splitting per se, but we have other solutions, so I'm going to talk about it later. Let's focus a bit on how we write web components on the right side. So HTML template, I can create a template like this, and what is powerful is that this piece of code will not be rendered by the browser, but it's available for you. It can be optimized. You can clone it, and you have a new component, a new instance of the component you want. Then we got the custom element. That's the main piece of the Web Components API. That's what's going to be rendered as a component inside your navigator. So as you can see, inside this component, inside this element, I can declare programmatically with JavaScript, we'll get on that later, a shadow root. It's the shadow DOM that I'm going to express here. And what is nice about shadow DOM is not only it encapsulates the style here, for example, but I can also slot elements from outside this component. And this is really good for composability. If you don't want to extend your component, if you just want to add other components inside, that's the way to do it most of the time. You would have placeholders inside your component where you can add in others. Right? Now, let's talk a bit about the history of web components now that we all know what features they provide. So we had a V0 spec back then. It started in 2014 with Polymer. How many of you have used Polymer before or tried it out? A few. All right. So it was only natively supported by Chrome. Otherwise, you needed some polyfills. More on that later. With the Blick engine since 2014, it has been removed very recently, or it was expected to be removed very recently. There are a few things that kept it living, but not for long. And it has a nice legacy. Okay, it's still a nice API, even if it's pretty dry. You can look at it here. So it's basic JavaScript. You work on prototypes. Yeah, it doesn't look like your fancy framework. You had this created toolback though, which was a very nice concept. You could create an element, and after you create it, it would trigger this piece of code, and you could add in any kind of content in there. And that was kind of powerful, and you missed that in the V1 spec. Then at the end, you could register your element inside your browser, and you'd have to register the prototype. So still very low-level JavaScript, okay? But this API has died now. Welcome V1. V1 is much better in terms of adoption first, okay? It's been adopted by all the major browsers. Even if Safari is the new IE and you tend to have some bugs in there, it's still pretty powerful and it can support most of it. It's going to be supported by Edge very soon. I don't know how many of you have tested the new Edge based on Chromium. And it's kind of good, so now you can use web components in there. And it's going to be released publicly pretty soon. The legacy, now we're talking about a real kind of framework feeling. We are doing object-oriented programming with web components. So as you can see, it leverages ES6 class programming. So you would extend an HTML element, that's a native element interpretable by the browser. And you would use inside the constructor, you would attach a shadow, so for your encapsulation, and you could add any HTML in there that would be encapsulated. That's how you would create a component. But still an issue about it is the support of all browsers. Because currently the V1 spec is only, its support is only in the evergreen browsers, so the latest versions. But for that we have polyfills, and we have two major polyfills. We have the Web Components.js, which is like the official one, supported by Polymer by Google. And we have the web reflection. I don't know if you have heard of Vanilla Javascript. He's kind of a genius, I would say, because he's full of ideas and he keeps pushing a lot of new ideas around web components, frameworks and all. I'll talk a bit more at the end for the frameworks. Be careful though with the polyfills, they're a bit buggy. For example, with IE. IE is the wanted man here. If you ever see it, delete it, please, and just come up with a new browser. So when we talk about web components, we're not alone. We have tools, all right, to develop. We are not completely naked here. Still, we have Babel support. You can choose whatever language you want. It will be transpiled to ES6. That's going to be interpreted by your browser. We got Webpack. Remember when I talked about code splitting? Webpack, sadly, is still necessary. If you look at all the other frameworks out there, we use Webpack a lot. Why do I say it's sad? Is that we do not have that many alternatives these days. We're a bit stuck. We're not that free. When you want bundling, when you want to import your modules and all, Webpack is the de facto standard. There are other solutions out there. There are other solutions out there that are being developed, like maybe have your NPM repository directly in your browser, for example, and it will be shared among your applications. These are paths that we're trying to explore, but for now, we're stuck with that. But we got also a lot of libraries and toolings like HTML, lit-HTML or StencilJS that will allow you to kickstart your projects, make it a bit more organized. Lit-HTML is very powerful. It's what Polymer uses in order to have a bit more templating for your rendering, okay? Make things binding a bit more faster, right? And we got libraries. Libraries, we can find a lot of them out there, but what web components are good for is providing design systems. When you got a design systems, you got a set of components that you can add anywhere, okay? And currently in Singapore, we have initiatives like this. SGX has been working on it for more than 2 years now. DBS has roughly 2 years of experience in this area, and they've come up with their own design system, so a set of components, very powerful ones that they can put inside their applications. We got initiatives also from GE, and they have open source there, so you can actually look it up for their IoT solution. And we got other partners like SAP and all that will come up with their own design system. So these are components out in the web that you can take and you can start with them. If you just want nicer look and feels, you got also Material UI. Be careful though, they've been coded in Polymer. So what this means is that they're still web components, but you will need Polymer runtime to run them. Okay, just a disclaimer. And of course, the library that will always fit your needs is your own. So get ready and just code it. This is my personal example for web components and full-scale applications. As it's written here, it's pure, it's lightweight, and I'm completely free. I can choose whatever I want. What does this mean is, it means that if I see that, for example, I have a dependency that has a security issue or something, I can resolve it on the fly. I'm not bound to a framework anymore. I don't have to wait for that framework to fix the issue. I can fix it myself. I have my own components in there, so I don't need to import too much. I don't have any issues with that. It's just the right amount of components that are needed, that I have in my application. And it's lightweight, very performant, because I don't have a middle layer. I don't work on another runtime. I work directly for the browser. I code directly for it. If you want, you can take a look later. I will put the URL at the end. But this is how I code, for example. What I like is to have mixins, so I'm completely free to use them. This is the way I code. I just create elements. I mix features in there. For example, if I want IITN, I just put it in here. And I have my own callbacks to detect where I would fetch my resources for the translations. But I'm completely free. I can do whatever I want. This is the render. You can just browse it up later. And this is the SGX website, and it's full of web components. If you look at your console, you would see only custom elements in there. They don't use Shadow DOM. But for example, this grid, they spent a few months on it, and it can handle more than, I think, 500,000 records very smoothly. There is no issue with that. It's very powerful. You can look it up. Okay? So we're done. So the future has won, more or less, because we see that the web components are kind of a solution for the future of web applications. Now let's start talking about the problems that arise in general in the web, so that we can see what are the pros and cons of the web components. The first problem, if you can read it, how many frameworks are currently in use worldwide? It's a lot. I've worked a long time on web development, and I can still see a lot of applications still written in Flex, in Next.js, old versions of them, in AngularJS. I think that was the worst, the worst decision ever that I ever made is write at least 3 applications in AngularJS, and now they have to be moved and migrated to the new frameworks. The problem is that at the time we needed time to market, right? Needed to be fast, we need code fast. And now we have a mess to handle, and we have to recode all this. That's one of the first issues. The second one, which technology am I going to learn next? That's always the question. I'm kind of tired, actually, to always hop from one technology to the other. I mean, I learned web development back in school, and it was all about JavaScript and CSS and HTML, and I was kind of okay with that. And then I had to learn all these new frameworks over and over again, and it's kind of tiring, to be honest. And the problem is that all the previous frameworks that I've learned, now they're dead. I can't even use them anymore. Goodbye, AngularJS, for the better. And we got a big problem here, is that whenever you use a framework, the first thing to go is the performance. When I interview people for React development position, when I ask them, what's the big thing that Virtual DOM can help you with in an application? The first thing they answer me is, oh, performance. And I'm very sad about this, because whenever you add an additional layer on top of the actual engine, you never gain performance. It's a trade-off. You lose a bit of performance, you have an overhead, the interpretation. You gain for something else. You gain things when you want to compare states, so it's easier to manage states of the components. You gain things like I can have multi-platform support, because you don't code only for the browser, you can have whatever you want as a targeted platform, but you don't gain performance. And that's one of the misconceptions here. You use more RAM. The problem with web components now, the Hateful Cons, there will never be any server-side rendering except if you run a browser in the backend. And this is an issue because Shadow DOM is so complex to simulate that you actually need a browser for that. And you always have 3 languages. I told you I'm fine with that because I come from web development. So I like HTML, CSS, and JavaScript, and I think they all matter. But people tend to want only one framework. For example, in React, you do CSS object-oriented CSS, and I think that's a misconception of things. And you have only one possible runtime, which is a browser. Where it may never improve, unfortunately, is the cross-platform point of view, except if you use PWA, of course, but it's still a browser running on your device, so it's not that performant. We will never have server-side support because of what I said, except if you use only custom elements. And we have actually Andrea Jamarchi coming up with a solution that's called Heresy. And it's kind of an heresy because he put everything in there. And he does support server-side rendering of web components because he has a virtual DOM layer. But he doesn't use Shadow DOM underneath. It's still a solution though. And we'll have a low-level browser API. What does this mean is you have to learn the basic things and you have to come up with your framework yourself. Don't expect a framework to tell you everything. You have to build it on your own, or you have to use another one like Polymer or StencilJS or Ionic for that, or for what it matters. It will help you a bit, but still, it's low level. Now we're talking about the pros. What can we gain in here? So if you look at that, that's pretty optimistic, right? It's pure web development. We're going back to the roots. No more learning new technologies over and over again. We have durable standards in there. I can still run HTML4 in my browser, and I'm fine with that. I can still browse the old websites. They're not dead. We have the fastest implementations out there. We don't need additional layer. We do whatever we want. We're free. We code for the browser itself. And we have future improvements incoming. We have a growing number of libraries. We have design systems coming in. We have initiatives from companies because they understand the value of web components. And we have third-party web frameworks awareness. What does this mean? It means that with your favorite framework, actually, or the ones that your boss is pushing you to use, like React, like Angular, or like Vue, you still have the support of including these web components inside your application, especially with Vue and Angular. You have your design system, write it in web components, you like it, you put it in your Vue applications, and it works. And we have further versions propositions. Today we're talking about web components v1. Tomorrow maybe we'll have a 1.1 and maybe a v2, and it'll be even powerful. So we're getting, if we adopt this standard, we can actually make it grow and make it even better. Right. So I think the pros have won, but that's my opinion. Now let's move on to the final standoff, if you will. Everyone's ready? Yes. All right. Let's start with Dance with Frameworks, or Framewolves. Okay, you remember, or maybe if you haven't seen the movie, I'll just recap a bit. At the end of, during the whole movie of the good, the bad, and the ugly is partnering a bit with the bad, a bit with the good. And here we're talking partnering with the good, right? What can we gain when we have good frameworks out there, very productive ones that everybody uses, and if we pair them with web components, what can we gain? So the first thing is, if I use Angular in my company or Vue.js, I can actually develop web components for the design system, and I can include them directly, and it will work perfectly. Because Angular and Vue.js are so close to web development, they're actually that good, in a sense, that they allow you to hook into the attributes, into all the very dumb, low-level things. So you don't need anything else, per se. The second part is, we have awesome frameworks out there. We have Polymer, we have StencilJS from the Ionic team, and we have Heresy, we have new initiatives like that, a bit like R&D stuff, and they help you create web components faster, which is kind of good. So we take the best from the web, which is frameworks, creativity, and all, and we apply that to web components, and it works perfectly fine. We have a good partnership here. Now, if we pair web components with bad aspects, what do we gain? We have these ideas of micro frontend, and I'm going to apologize now if any of you is doing a micro frontend presentation later. Sorry. But if we use web components to wrap a component that has been written in either React or Angular or Vue or whatever framework is out there, you hide the complexity of this component, of course. But the problem is, you still have something to maintain. And you have other issues in there. I don't know if any of you has ever written anything for portals back then, LifeRay, WebSphere, maybe. And we had this very big issue making intercommunication between portals. It was pretty hard. And we had problems with resource management and everything, and we're getting back to that. If you have a component that's been written in React and you want SSR just for this component, you'll need a microserver just for that. And then in the rendering part, you would have one version of React, for example. But what about if I want to use another component that's in another version of React? And it's not backward compatible because for some reason they didn't want it. What am I going to do? iframe it? Not sure. So this is kind of an issue here for the micro frontends. It's a trendy concept, but I don't see any simplicity in there, to be honest. Now we have our standoff. So when we have the web components that are trying to compete with the good, actually they lost. Sorry there. You have to fight another battle. Coding productivity is one of the main things that currently the frameworks allow you to have. And web components were still not there yet. Even if Polymer is quite good, we cannot compete with things like React. JSX is awesome, to be honest. But when we try to fight the bad, the runtime performances, the standardization, the long-term survival of our applications, then web components make sense. Because there's no virtual DOM, there's nothing to maintain between your code and the browser. There's nothing to choose, you just choose the browser and it's going to handle it. It's going to be backwards compatible. I'm telling you that now, current browsers, they still can run your old websites, right? That you developed in college or wherever, whenever. And when they, again, fight against the bad, one of the main things is that you're in control of everything. So you decide what you want to patch. You decide if you want to add security. You decide if you want to use a library that's really powerful and the other frameworks don't use it for some political reasons. You're completely in control. Just a word now about green coding. When I presented myself, I forgot to tell you that I'm kind of an advocate of green coding. This is an initiative coming from France mainly. And what we try to do is to make people aware that we can code in a way that's responsible either for the Earth or for the population in general. So basically, when we want to provide a service, an application that provides a service to you, then we would focus on things like that. Performance. You don't want to wait when you access your applications. And this you can use web components because that's the fastest implementation for components. We have optimized solutions, meaning that they will not use that much resources. You don't add another engine on the top. You don't do useless computation. You're in control of what you do for the rendering of your components. They're discrete, meaning that whenever you use them, you don't have to pull a lot of libraries that you don't want running in your browser. Remember event streams? Ring a bell? Yep, that was kind of harmful. So it means that you're completely in control of the libraries you use, but if you take a library inside a framework and they have not patched a version of the library they use, but this library is either buggy or there's a virus in it, you're stuck with it. So with web components, you can react faster. We have durable solutions. We can run them in 2, 3, 5 years maybe, even more, if WebAssembly has not taken over. Let's see that. Inclusiveness. What does this mean? It means that you provide your application to everyone, and this is where there is a bit of work to do. Do you know why? Browser support. You remember? Yeah? We talked about polyfills. We can still support the older browsers, but the problem is then we have another layer, we have an engine, we have a runtime, so what's the point? We can use another framework, we're going to have the same things, we're going to have the same performance, because polyfills, they will bring you the dependency that you may not want. So that's why we're still not there for the inclusiveness, but we're getting there. So to wrap it up, the good, the bad, and the web components. We got the good part of the web today. We have productive frameworks. They're accessible. Everybody that I've interviewed knows how to code a React application. And not just a hello world, to be honest, they can do pretty nice stuff. Not gonna lie, it's pretty neat. But we're still left with a bad mess. Got so many applications out there that are not maintainable anymore, and we lose money in there. Just show that to your boss. Look how much money you have to spend to maintain these things or to migrate them. Maybe we should stop at some point. But we got the ugly web components. I'm saying they're ugly because they're still in an early stage. It's a first attempt at standardization. They do not cater for everything. Okay, they're not that inclusive. They do not provide you the same kind of productivity that you would expect, but still they're a solution. And they're more performant. They give you a lot of things. Okay, there's a trade-off, of course, but they can provide you performance. They can provide you durability. They can provide you all the things that I showed you for the green coding part. Now let's wonder. There is no real right or wrong, but what do we want to focus on? This is a question I would let you solve this thing for yourself. One may wonder, when do we want to settle down? We are creative, we are pushing the frontier. When is it a good time to actually start building something durable? And our all-stars, Diana Bermoff, even you, all these people, are they still going to be here to help us do that? I mean, John Reisish, I don't see him anymore, the creator of jQuery back then, right? So we're good. We have a good partnership with the good of web components, and we can actually vanquish the bad out there. That's very optimistic, I'd say. Don't you think? Right? Thank you. Hopefully we can ride into the sunset together to the web components. Thank you. Okay, let's stop at the saloon. If you got any questions. Anyone? Yep.
Can in terms of testing shadow DOM?
Testing shadow DOM? I can do it. I use, you can look up, let's go here, my one template demo. This is a very bad pun, actually. It reads one template. Sorry for that. In there, I test web components directly, and you can test shadow DOM because when you use Mocha and Chai and Karma actually spawns a browser for you. It can be headless or not, but it will still run web components, so you can still use, can still test shadow DOM in there. So you can look it up. Yep.
So you mentioned that server-side rendering is not supported, but if you use JavaScript apparently only for enhanced features of interactivity, then what you actually render in a component is perfectly renderable on the server side, and
yes.
The browser and even accessibility features can just ignore the text that you don't understand and be able to even support screen readers and things like that. Don't you think so?
Yeah, we can. So there are multiple questions in there, right?
Right. First about the server-side rendering, and second about accessibility.
So server-side rendering, if we go back to what's the necessity of server-side rendering first, people tend to do server-side rendering when they want better search engine detection, so SEO, when they want to make it better. Currently, we have Google search. Their Google bot has been improved, and it's now running on an evergreen browser. So if you use web components in there, the V1 spec, Google bot will actually detect everything, all your content in there. For the fact that we can still render in the server side, I would say it's still powerful, but do not use shadow DOM. I mean, shadow DOM is very heavy. It's also kind of heavy on the browser currently. So if you avoid using shadow DOM at all, you can actually even run it in the backend, the rendering of your component. You don't even need virtual DOM per se. So it can still be supported, but not the full API of web components. Does this answer the first one? No, not completely.
What I mean is that shadow DOM in components is supposed to hide all this accidental complexity of a particular tags and things like that.
Okay.
And the template itself in a component would mean that it's a semantic HTML. It can be rendered on the server and will be understood by bots or legacy tools as well.
It's actually a misconception of shadow DOM. When people talk about shadow DOM, they focus on shadow and they think that it hides things. And that's not true. We don't hide. And to be perfectly honest, people don't use closed shadow DOM anymore. They use open ones, and it's even recommended. Shadow DOM is here for multiple things. It's shadow, so it's like a subdocument. It's mainly for encapsulation and slotting. Slotting meaning that if you have other components that you want to slot inside your component that has a shadow root, you still have your component on the side, and the screen reader can just access it the same. So you won't have this issue of accessing the shadow root. But even this part put apart, you can still read the shadow DOM content, actually, because it's open. It's just that it's less accessible because you need to do .shadow root and .something afterwards to query anything in there. But the screen readers, normally they would adapt and they would see that. If you want to be sure, use that in a slotted component if you want to use shadow DOM. But still, yeah, it's supported.
Thank you.
Okay. Anyone else?
First of all, we have two web components. How we can communicate between two components?
Two components?
Yeah. How we can communicate?
Yeah. So how do we communicate between web components? You can use anything that's available out there in the web. So you can use custom events. You can use events, and then you would add even listeners anywhere. Or you can just call directly the component with either updating their attributes. In the spec, you can listen to attributes changes, and you can listen to certain attributes changes, so which is a bit more performant. You don't need to listen to everything. So whenever I would change, for example, the value of my component, I would then in JavaScript know what to do when this value has been updated. So that's one of the things. And the other one is the event path.
So which one do you suggest? Which approach do you suggest?
What do you mean as a framework, as a template? What I would suggest in general? It depends on the use case. You can still look up my example. I use a bit of both. Sometimes, whenever I want to communicate to the platform that I'm doing something with my component, for example, I pressed a button, I would emit an event, and whoever is interested would catch this. But if I want to use one component in general, maybe I would not send just an event. If I'm a parent component, I would just call the accessible API of that component, because you can also provide public methods on it. So it's a bit of both. Anyone else?
Thank you. I have two questions. First one is, of the music you use at the beginning of the speech.
Sorry.
The music you use at the beginning of the speech. What's the music?
Sorry, I didn't.
The music you use at the beginning of the
Oh, the beginning. It's the good, the bad, and the ugly. It's the movie theme.
Okay.
Sorry.
The second thing is, I mentioned that if different components came from different libraries,
Yes.
how do we handle that?
If they output web components like Polymer and all, it's fine because you're still developing for the web. It's just that the runtime, you will need to import Polymer, for example, to run it. But afterwards, it's a pure web component, so it's the same answer that I just had. If it's using something else underneath, that's what you're referring to, like maybe wrapping.
I mean, if you have two components, one is using maybe a library version 1, the other one is library version 2, does this create any issue at runtime in the browser?
Yeah, that could, because when you import a library, it has to be versioned. But here for web components, you don't have that issue because there's only one spec, so it's the one that's handled by your browser. If you want to...
But the component behind may use other libraries. It might making the not from different provider. Maybe this one from one repository, the other one from another repository, then you try to...
You won't have any issue because it's still the same runtime that runs both. I mean, if you write your web component with some kind of tooling at SGX, for example, another one at DBS, and you want to make them interact, it's going to work because they run with the same spec. They run with the V1 spec. You don't have any problem making them communicate, and that's the powerful thing. You don't need to have the exact same version of writing your component in React V10 or something, and then you have another one that's going to be coded later in V20 in the future, and make them communicate would be harder. You never have this issue here because you use web development, pure web development. So you would use events and just method callings to make them interact. So you would go through the very basic low-level API, which is mostly event handling in the browser. So you would code everything in Vanilla JS. Does that answer your question? Not quite.
Not really. I mean, for example, I have created two components.
Yes.
Two teams.
Yes.
One team is using maybe the next jQuery. The other one is using a latest another jQuery version.
Oh, then you're talking about two different libraries. But that's the thing. That's what I'm talking about. If you use libraries in there, you don't create pure web components. So you're talking about the bad part here. You're talking about what I call the Western spaghetti in there. So no, that's a very big problem actually. You can't really solve that. You have to upgrade either one or you downgrade the other. Or you can namespace jQuery in your case because you're talking about jQuery, and jQuery has this nice thing that you can namespace. You can namespace your jQuery version. But that's just jQuery. If you use something else like React and all, you won't have this capability.
Okay, thank you.
Sorry, thanks. Okay. Anything else?
Just a simple question. So we have a
Sorry, okay.
Sorry. So we have a framework like Angular, React. They're like backed by companies like Angular, like Google, and React.
Sorry, I really can't hear you.
Am I audible now?
A bit more, yeah.
Yeah.
Thanks.
I'm saying that we have like frameworks like Angular and React. They're backed by different companies and they have very good support. And they are built on some standards that when you're writing Angular application, you write some core standards. So what about the web components, like which standard that somebody is starting to follow? Is there like standard that everyone follow like that?
No. No, because it's a low-level API, so you would do whatever you want. You can either use an existing framework, like I say, StencilJS is quite good because you use TypeScript and also it adds another layer of organization. You have a Polymer that also makes you a bit more productive. But other than that, it's your call. You would apply your own standards. If you look at my example, you would see that I don't like, for example, extensions of components. I don't like inheritance, so I would use mixins in order to add features in there. So I would forbid inheritance. I have things like I will not completely hook to some of the lifecycle events. It's my own preferences, to be honest.
Don't you think that no standard means like it will create chaos and like you have so many people like doing different things in their own way?
And that's the responsibility of the frameworks. And that's why frameworks are still good and they're still okay. It's still okay to try to come up with some on top of it. Like I would say that if we have at one point an upgrade to the current web component spec, it would be to get closer to what React can bring in terms of productivity. When you use JSX, it's awesome because you don't have to worry about a lot of things. You don't have to worry about adding listeners manually with JavaScript. You don't have to worry about scoping. You don't have to worry about state management. And if we can bring that as an option to the web components, like state management, it would be perfect. It would be great. But it should be an option. You should not be forced to use that. That's the whole thing. So maybe one day we'll see that coming, but let's see the adoption rate. Thanks. Anything? Anything else? All right. Thank you very much. It was a pleasure doing this.